To begin this lab, we prep the pH meter by rinsing the electrode with distilled water, dabbing the electrode on a paper towel, and then placing in the first phosphate buffer, tilting the beaker so that the end of the electrode is completely immersed in the buffer. We then calibrate the pH meter by pressing Calibrate Now and entering the pH value for that buffer, in this case 4. We then rinse again with distilled water and then place into the second buffer, using the tilting method again, and then entering the pH value for that one, in this case 7. We then save the calibration to the pH meter to use for the rest of the lab. After this, we rinse again with distilled water and then store in the prepared buffer solution for that electrode. A buffer is a solution that can resist pH change upon the addition of acidic or basic components. It consists of a weak conjugate acid-base pair in appreciable amounts at equilibrium, making it able to neutralize small amounts of added acids or bases and maintain the pH of the original solution. After the pH meter is prepped, we are able to use it to find the pH of the provided solutions. We rinse the electrode with distilled water, dab the end on a paper towel, and then place into the solution. When the pH meter rests on a number, we can then record it in our lab notebooks. Rinse the electrode with distilled water again, and store in the provided buffer solution. A strong acid dissociates completely in a solution, while a weak acid only dissociates partially. This means that in a solution, the concentration of the strong acid would equal the concentration of the H+ ions, and that the acid's Ka, or equilibrium dissociation constant, would be very high. A weak acid's H+ concentration varies based on the concentration of both the acid as well as the concentration of the solvent that is mixed in, and its Ka is much lower. By the end of this lab, you should be able to use the pH meter to find the pH of various solutions, as well as determine a strong or weak acid.